Good morning, everyone. Can you hear me? Good. How about Sean? Can you hear me?
Yep, I can hear you.
All right, perfect. And let's see. Welcome to Demystifying Networks, Lunch and Learn. My name is Yuli Newsom. I'm a member of the services team at Cisco. And the goal of this training, and this is what I'll explain in a couple slides here, is to help our customers with getting value realization out of the training, out of the investments that they make. So again, my name is Yuli Newsom. A bit about myself. I've been at Cisco now for about 4 years. I started my career in the military. I was a medic, then went to do nuclear engineering on submarines stationed out in Guam. Then came back to the US. I taught a couple courses, naval engineering, naval weapons systems, and then went to work at a couple companies, Dow Chemical, started a company to help military families transition to civilian careers, and then went to Salesforce, and now I am at Cisco. The agenda for today is us doing the welcome. We'll then have a presentation by my colleague, Sean, who's virtual on the East Coast. And then we are going to do a Q&A session. During that session, if you wouldn't mind waiting until we get a microphone to you so that the folks that are virtual can also hear you as well. Are the slides coming up there, Eric?
Are you sharing?
Maybe I'm not. Let me, I might be the issue. Let's see here. Back to meeting. Perfect. Okay, there we are. Thank you as always, Eric. So yeah, welcome. That's what we're doing now. Presentation, which we given by my colleague Sean, and then we'll have a Q&A session afterwards. First off, want to thank you. Thank you for taking the time to join us today. And for the Cisco customers, thank you for being Cisco customers. We know that you have options, and we are appreciative of you choosing to do business with Cisco. The goal for these lunch and learns is to help with value realization. So the way that we're going to do that is by helping out with learning. Learning from experts, expert learning, and then also peer learning. So the way that we came up with the first couple of sessions was that we just looked at what our customers in California were buying. And then we said, okay, what would be helpful if we brought an expert in to come and talk about those topics. But feel free, you all have my contact information for future sessions. If you think there's something that would be more helpful, say, hey, yeah, we'd be really interested in learning about this topic. And it's really simple for us to then go and grab a expert, bring that expert to you, and then start getting questions answered. But then there's also the peer learning. So I think I mentioned that I was a teacher for a while. And both as a teacher and also as a student, sometimes you just need somebody else who's going through it with you to give you an example that the instructor can't give you. And that's what this is for. So we're bringing all of our customers from the different agencies together that are working on similar problems, allow you to connect with each other, and then hopefully that also will be a resource for you to get value out of your investments. So as I said, we do have a list of trainings that are coming up. All of these next ones will be at one of our customers, Cal OES. And the next one is going to be collaboration focused. You might know that Cisco has a big conference, Cisco Live, coming up. So our solution engineers are going to go to that, and then we're going to bring that to California and have a session specifically for our California customers where we're explaining what the latest and greatest is from Cisco so that you can get it, just in case you're not able to go to Cisco Live. Then we're also going to have a session, data privacy and security, particularly as it relates to artificial intelligence. And then finally, we'll have another session, which is implementing automation for Cisco Enterprise Solutions. This I will get out to you this week. We are just buttoning up some things with respect to the actual date and location. So Cal OES has a lot of buildings, and we want to make sure that we get the right one to you when we send this out. So again, thank you very much for your time and coming to this session. And now I will turn it over to my colleague, Sean, for the bulk of the presentation.
There we go. Sorry about that. Good afternoon, everyone. My name is Sean McCracken. I'm a senior wireless consulting engineer at Cisco. I focus primarily on the 9800 series controller, but I do pretty much anything wireless related, so we'll be covering several topics here today. So on the agenda that I have, we've got, oops, too far. We've got just a quick overview of the 9800 series controller and how it operates compared to the AirOS controller. That'll be where we cover in our tagging for success section, just how we cover tags and profiles and setting that up. And then we'll have a section on dynamic channel assignment and radio resource management. And then how we'll be controlling a lot of that in the profiles. Cutting the chatter, that's mostly focused on best practices regarding how many SSIDs you should have and why we don't want to have too many. And then we're going to have some basic troubleshooting tips, and then we'll go into the Q&A. So I do also have a lot of extra slides on this, so if anyone's interested in the slide deck, I can pass it. Some of these slides I'll just skim over as they're more informational, and they don't really require me to speak too much on. So starting off with this is our intro into the 9800 series controller. We now have several models, including our new 9800 H1, H2, and M models, which are basically just more robust versions of the previous 40 and 80 models. They basically just have more CPU, more memory, and they're down to 1U rack size instead of the previous 2U units that they used to be. So basically their feature set is pretty much the same. They just have more processing power. The next follow-up question to this is usually regarding to software versions. So we currently have a bit of a three-way split on the recommended software version. So if you have mostly older APs and you don't have any of the new 6E access points, we're leaning towards 17.9.7. If you have any of the new 9160 access points, will be 17.12. And then if you have the new series controllers, the 9800M or H1, H2, and the respective Wi-Fi 7 access points, they'll be 17.15.3 is our current release. These update pretty regularly, so keep an eye out, but for now, it's kind of just an awkward three-way split. So moving on to this point, we're going to talk about a quick understanding of the controllers versus AirOS. So on AirOS controllers, like the 5500 and the 8500, we had multiple layer 3 interfaces, one for basically each network that the controller was advertising. In the 9800, we basically only use one layer 3 interface, and that's just the management interface. So that should be your only layer 3 interface. It's pretty common to see conversions if you were to do a config translation from an AirOS controller that you'll end up with a lot of these, but you really only need one. Our goal is to pretty much limit the layer 3 traffic that we're exposing the controller to as much as possible so that it only really sees management traffic at layer 3. Now, most of our other traffic will be sent at layer 2. So broadcast traffic, just like a layer 2 switch, that's primarily how the 9800 operates. So moving on. So this pretty much just recaps that. We do have multiple interfaces, but primarily The only two interfaces that you'll really see IP addresses on will just be the management interface, and then if you opt for it, the out-of-band interface. That one is optional. It's really just used for reaching the controller GUI. And then we always recommend, just for redundancy, to have an uplink trunk. So that's a port channel, either mode on, mode active, or desirable, whichever option. We support all of them now. So whichever one you prefer. So there are a few reasons where you may need extra layer 3 interfaces. That's pretty much with MDNS and DHCP relays. The relays is less common. We would really only do that if it was a very small network, because we're trying to reduce the strain on the controller by handling all the extra layer 3 traffic. Remember that even if we're not doing much ourselves with the layer 3 interface, we still get all layer 3 traffic in broadcast or multicast that are going to be going across that link, and the controller has to respond to all of it on top of managing several thousand wireless clients. All right, so with the quick overview done, we're now going to move over to the hierarchical view of the controller. So unlike AirOS, the 9800 functions primarily off of tags and profiles, as opposed to AP groups like we saw on AirOS controllers. This is a very similar system as far as what you configure and how you configure it. The main difference being that it's much more modular and much more easy to mix and match. So if you will need to change one thing, you don't have to spin up an entire new group, reconfigure the group, and add all the sections in. We would just alter one small part of the profile and then change the tag to reflect it. So the three main tags that the 9800 uses are the RF tag, the policy tag, and the site tag. So the policy tag is basically what's responsible for what is being broadcast. That's what WLANs you're broadcasting, what kind of security they use, and so on and so forth. The site tag is a twofold tag. Primarily, it's used for grouping, and it's just logical grouping. So in a local mode controller, it has very little impact on anything except for the WNCDs, which I will explain shortly. In FlexConnect, it determines which sites are FlexConnect and which sites are local mode. That's its main purpose, is basically just a hierarchy breakdown and assigning things to different sites. And the RF tag is just the RF tag. It determines what RF policies we're applying to the 2.4 and 5 gigahertz and 6 gigahertz radios. By default, the default tag just uses the global settings. If you assign it a specific tag, it'll use whatever profiles are assigned to that tag. Okay, so this is a breakdown of what the tags look like. So the policy tag is comprised of two components. It's got the WLAN profile and the policy profile. The easy way to remember this, as it's by far the most important tag as far as operations go, is the WLAN profile is what is anything going over the air. What SSIDs you're broadcasting, what bands you're using, what security those bands are using. Pretty much anything talking to the client is on the WLAN profile. The policy profile is going to be your layer 2 component. So this is going to be your VLAN, your ACL, AAA override, DHCP, broadcasts. If you're doing any radius or profiling, it'll all be on the policy profile. You put both of those together, that gives you connectivity to the client and then connectivity to the switching side, so we build the bridge between both. The site tag is primarily conformed of just the AP join profile, unless you are a fabric network, and then you'll also have the fabric control plane in here. But it'll mostly be the AP join profile. If you uncheck mark local site and make it a FlexConnect site, then you'll also see a FlexConnect profile. The FlexConnect profile is basically the same as the FlexConnect AP group in the AirOS in a slightly different place now. Now, any AP you assign with a FlexConnect site tag will automatically convert to FlexConnect. You don't have to go and change the mode or anything like that. You basically just have to assign the tag, and then it will swap to FlexConnect. And then, as we discussed on the RF profiles, they're basically just the 2.4, 5, and 6 profiles that can be configured individually, or you can use the global settings. So this will show some of the components for the WLAN and policy profile. As you can see, we see mostly WLAN related configs like SSID, layer 2 security, layer 3 security, P2P blocking, and then our 802.11 standards like KV, R, W, etc. And then the policy profile will have like your session timeout, your idle timeouts, QoS, ACLs, anything basically related to the switching config. Now, the next one we're going to cover is why we wouldn't want to enable just a ton of SSIDs. And the basic answer is, for every SSID that the controller is broadcasting, every 100 milliseconds, the access points will send out a beacon to say, these are all my networks. And that is every 100 milliseconds, regardless of when you finish. So if it takes you 10 milliseconds to advertise all your beacons, you only have 90 milliseconds to talk to clients before you have to advertise your beacons again. So the more SSIDs you have, the longer this process takes, and the more APs that can hear it, it takes even longer. So if you have eight access points in earshot and you're broadcasting 6 SSIDs, you're losing 13% of your using 13% of your bandwidth to overhead, to wireless overhead, basically. So the best practice is that we want to have 3 SSIDs or less, and you can stretch it to 4 without suffering any major penalties, but anything over 4 and you start taking like incrementally more overhead loss and throughput loss for every SSID past 4. And it gets to the point where it can be very significant in terms of how much speed you're losing and how much throughput you're losing. You'll also have more collision, more packet retries, and it just gets out of hand really quickly. I've seen customers that are broadcasting 9+, and they'll have 40% of their packets having to be reset constantly due to just constant collisions. So, and now we'll talk about the quick components of the site tag. Primarily, the site tag doesn't contain much that you'll really ever mess with directly, but it does have a few highlights that you may need to look into for different types of deployments, particularly FlexConnect. But the big ones are the TCP MSS interval, the retransmit interval for CapWAP, the retransmit count for CapWAP, and then .1x credentials and SSH/Telnet credentials for the access points if you'd like them to re-sign back in. Or the main ones, there's a bunch of subsections. And then for the Flex profile, you have the only real ones are the native VLAN that the local site will be using, and then local VLAN that the AP will need to be tagging traffic to, as well as local ACLs that it'll need to be applying to clients. But the rest of them are mostly on by default, and it's rare that you have to change them. Okay, so now we're going to talk about load balancing. On the 9800, the load balancing is important, and this is dictated by the policy tag. So if you assign all of your sites to one, sorry, it's applied by the site tag, not the policy tag. If you assign all of your access points to one site tag, you basically end up in this scenario where you have one CPU doing all the work and all the other CPUs are just watching. So the big distinction here is that for every site, we typically want to have its own tag, or at least have it broken up enough to be able to spread the tag, spread the APs across all of the instances. So for instance, on a 9880, we have 7 WNCDs. So if we had at least 7 tags, some APs would be in every tag. There is a minimum and maximum for each tag, but the general recommendation is you don't want to usually have more than about 300 to 500 access points per group, depending on the size of the controller. So an 80 can have about 500 without any real issues, and a 40 can have about 300. Anything more than that, you'll start straining individual instances, and then you'll end up with a rotating crash that's not very good. So the general recommendation is we just want to break this up as much as you can. You can have, it's way better to have way too many than not enough. How they're separated doesn't matter overly much. You can do per floor, per building, per type of building, you know, a room type, as long as they're broken up. Everything else is basically just to make it easier for you to identify them and to help split them up as like according to what they're supposed to be doing. The only exception to this rule is the default, or the flex profiles. You cannot roam smoothly between site tags if they're FlexConnect. So you don't want to have a FlexConnect building that has multiple floors and every floor is its own site tag, or you will disconnect every floor. So for smooth roaming, flex profiles should be all one building, one site tag. But if it's local mode, you important that you segment this. Otherwise, you'll end up with a very lopsided controller and only one CPU is doing any work and everybody else is just relaxed. Okay, and then so by default, if you use the default site tag, it basically just round robins all the APs between each instance. This is typically not desirable as it creates a lot of extra load on the controllers, as every time you move, you will basically move between instances. And that just means the CPU has, for every client, every time they move, will have to engage to move them. Moving between site tags periodically is not a big deal, but every single roam requiring a move can be quite strenuous. So it's better to do this bit manually by just creating the tags. It's also worth noting if you use Catalyst Center, the Catalyst Center will basically do this for you. It will create an individual site tag for every floor of every building that you provision APs on. So it kind of takes the load of thinking about this off the table and maximizes the efficiency of it. So that's a good plus. So here are the site tag considerations. For the different WNCDs, you'll see we have the number of instances. These carry over on the 40 and 80 directly to their M and H1, H2 equivalents. So the 9800M has 5 WNCDs and the 9800 H1 and H2 both have 8. So this will basically kind of show how we split the tags up between the instances. This is done this way to provide some resiliency. So each instance has its own CPU, its own memory, and its own data plane. So if something were to go wrong or your instance crashed, you would only lose the APs associated to that instance, as opposed to the AirOS controller, where if we lost something on the data plane, we lost the whole controller, the whole thing reloaded, every site went down. So this helps compartmentalize some things and helps reduce some of the strain. It also makes it more efficient, as no one site can chew all of the resources from other sites. Even if you were to overwhelm one of the WNCDs, only that WNCD would suffer. So we granted want to avoid overwhelming the WNCDs, but it's much easier to do that when there's more than one. So for high density, we have a few other considerations, but typically it's best to just keep track of the AP counts. If you have a very large building, say you have 1,000 APs in a multi-story building, it's better to take multiple site tags and break that building into pieces, say 300 per every couple of floors, like floors 1 through 5, 6 through 10, 11 through 15, or so on. Or you can do a per AP floor. Either option is fine, whatever works best, as long as we break them into pieces so we don't have one giant chunk of access points being assigned to one WNCD. So here are the site tag limitations. These are hard limits. If you get to the point of reaching any of these, you'll notice pretty severe degradation to the controller's performance. So if you hit 800 access points, that's the most the controller will allow you to assign to an instance, but you'll start noticing degraded performance before you get to that point. So that's why we usually recommend not breaching about the 300 to 500 range. If our general rule of thumb is if your access point is, your controller is more than 70% utilized, it's probably worth looking into a second controller or expanding it to a larger spec controller. So if you're almost maxing out a 9800M, it'd probably be better to upgrade to an H1 or an H2 variant to give you a little more breathing room, because sometimes different types of traffic can consume more memory, even though the amount of access points haven't increased, such as multicast or MDNS, and that can push you over the threshold for consuming too many. So here you can see that our recommended number of site tags for each controller is about equal to the amount of WNCD instances they have. That's just to make sure that some APs are in each instance, and each instance is contributing to the overall performance. Here are a couple useful commands. Like I said, I can hand out this slide so you guys don't have to memorize these. But there are some good commands just to see what instances the access points are assigned to, and then how many are assigned to each instance, so you can see if you have an unbalance. It's pretty easy to rebalance them by either splitting them into different access point groups with different site tags, or there's a command to redistribute, but that one's I wouldn't recommend using unless you were advised to by TAC. Okay, so here's the components of the RF tag. This components are basically the same as the global RF configurations. So we'll have like the data rates, the MCS rates, maximum and minimum powers, DCA channel width, the channel listing, if we're doing any coverage hole detection, and then we have multicast and RxSOP band rates, as well as band select and load balancing. Okay, so now that we started talking about that, we'll slide more into the RF section. So this one is one of the most common things that I see missed in a configuration, and that's the DCA interval. Starting off with, the DCA interval is always 10 minutes. This is generally because when you install a new controller, the controller has to recalculate all of the channels and power for every access point on the network until you hit a comfortable spot, shall we say. And basically, it does this by running a calculation and comparing them, but the controller will only change the worst offenders for RF and channel at a time. So it takes several hundred iterations usually before you hit a good balanced power level / channel layout. And this means that you want initially the controller to go through as many cycles as you possibly can. So if you set it to 10 minutes, you can wait a couple of days, usually over a weekend. Best practice is if we can do the change on Friday, by Monday, it should have went through enough cycles to say you need 300 cycles for it to level out. That means it would take about 30 cycles of 10 minutes or, just over a few hours. It's not too big of a deal. But if you have your DCA set to 4 hours, going 300 cycles would take you months. It would take a long time. So the goal here is that when we first stand up the controller, we want the DCA to be very short. And then once we hit stability, the channel layouts look good, the powers have all adjusted, then we want to increase this to an amount that runs at least once during the day. And it's very important that it runs at least once during the day because this controller does not look at historical data. Its DCA decisions are based off what it sees right now. So if it sees an access point is doing interference right now, it will fix it. But if you have it run, say, at midnight every day and no one's in the office, it doesn't see interference, it doesn't fix it. It just leaves it alone. This is where the big push for AIRRM comes in, as AIRRM does take into account historical data, and it basically will calculate based on whatever it saw throughout the day. Although it uses a similar algorithm to the way the rest of our controller functions, it does it in a way that takes into account things that it's seen before and not just what it sees right now. But the goal is at least once, so we recommend 4 to 6 hours. If disruption is something you're worried about, you can push it up to 12 as long as it runs at least once. You'll also notice on the screenshot here, we have a little section called anchor time. The anchor time is basically your offset from midnight. So anchor of 0 means it runs every 10 minutes starting at midnight. So if you were to set this for 4 hours, it would run at midnight, 4 a.m., 8 a.m., 12 p.m., 4 p.m., 8 p.m., midnight, right? If you set it to 1, it'll start at 1 a.m., 5 a.m., 9 a.m., etc., right? So that lets you offset if in case you want it to run slightly before everybody's day starts up or slightly after, depending on your scenario. So these are the mandatory data rates that are also pretty commonly missed. The important aspect of this is that all wireless clients are subject to the slowest user that is on the access point. So if you have a very slow user on an access point, everybody else has to slow down to match their speed. Because we basically, if we transmit at a rate that's faster than a client can keep up with, they can't understand what we're saying, and they don't know if we're talking to them. So the important part here is that we want to increase this to the maximum we can get away with while still allowing every client to connect. This also has the upside of making roaming much better. If you have low rates enabled, like 9 or 6, you'll bump into issues with sticky clients where clients will just simply not roam when you want them to, and they'll stay connected to an access point that's much farther away than they should. So by increasing the data rate, we force the clients to have to roam more frequently to stay on a good access point, and we also increase the overall transmit speed of all the clients on the access points because they all have to talk at the same level. So the DCA planning, this is basically what channels we're allowing to push out. Typically, we try to, the more channels is better. The more channels you can use, the better. Width is A little trickier. Generally, you don't want anything over 40 megahertz in an enterprise environment. We simply have too many access points to utilize 160 or 320, even though I know it sounds cool to be able to go super fast, but in the reality is it just takes up too many channels. A 160 megahertz channel consumes 8 channels out of 24, so you'll only have 3 access points that have non-overlapping channels, which makes it pretty unappealing. 20 to 40 for a standard data client like a cell phone, laptop, or tablet, anything like that, about 90% of their data is sent at 20 megahertz, even if you have 40 enabled. So you don't really lose much speed. It's only a device that's doing particularly heavy uploading that will breach into doing 40 megahertz bundles, like if you're doing a download, software upload, or you're streaming a large amount of data. But most of the time, all your generic email updates, WebEx Teams, all that is sent at 20 megahertz. So you really don't lose much by downshifting, and it makes your channels much easier to manage, and you'll have much less overlap. And we cover that a bit here. So the biggest thing is 6 gigahertz being the exception to this, and this is a popular topic because the 6 gigahertz is quite new. With 6 gigahertz, we have about 58 channels. So you actually have plenty of channels that we actually recommend doing 80 megahertz wide. And we recommend this for a few reasons. One, because the amount of time it would take your client to scan 58 channels is longer than is actually feasible to roam. Your client will take so long trying to scan all the channels that they'll just not roam. They'll fail and have to reconnect locally. So we recommend 80 megahertz, and that'll put you on the what we call PSC, or preferred scanning channels. And then it only has to scan about 20, I think it's 23 or 24 channels, roughly the same as it would on a 5 gigahertz network. So you'll get much more bandwidth, and you'll also roam about the same speed as you would on 5 gigahertz. So balancing the transmit power, this is also one that gets missed. By default, the controller runs at a negative 10 and plus 30 for the minimum maximum respectively. So negative 10 would be the minimum and 30, positive 30 would be the maximum. The access points are actually not capable of hitting any of these values. So the access point cannot go to negative 10 and it cannot go to 30. They peak out at like 28 usually. So this is to say that the controller basically doesn't put any limit on them. It lets them go to whatever they want. Typically, this is not ideal as they will power down. Keep in mind that the access points, when they're balancing their power, they're not balancing based off what they hear from their clients. They're balancing what they hear from other access points. And the access points themselves have very strong radios. So they'll be able to hear themselves much better than they can hear a client. So to get this, what we usually want to balance this to a rather high minimish. You want it low enough to be able to back down, but not so low that it can turn off. So usually if it's a high density deployment, we'll recommend somewhere between 4 and 8 dB so that we get a nice cell balance without having the access points reduce power down to 0 or -1. On surveys, I've seen the access points power down to -3, which is functionally just off. They're basically not sending anything. So getting this balanced out, it does take some tuning. This is also non-impacting. So if you see your access points are all a little too strong, you can change this. It doesn't have any effect on the clients. It's just the next time the APU runs its cycle, it'll reduce the power a touch. The power threshold control, which is down here at the bottom on the screenshot, it controls the average power level that we're trying to hear. So a quick lesson on how TPC works is basically every 3 minutes, the access point will send out something called a neighbor discovery beacon, or an NDP. Every access point will report back to the controller what they hear that beacon at. The goal of the controller is to make the access point hear that beacon at whatever this threshold value is. So the controller will say, okay, you heard that beacon at -58. That's a little too loud. Turn your power down so that next time we hear it at then we'll run it again in 3 minutes. We'll hear it at -62. It'll be like, it's still a little too loud. Turn your radio down a little more. And it'll do this for every single access point to try and get you an average power level of about -65. -70 is the default for this. -70 is typically fine in most cases. If you find your access points are all a little underlevel, a little underpowered, or a little overpowered, you can tweak this plus or minus, and it'll bring your average level down or up, depending on which level you shift it. So if we wanted your radios to get a little louder, we could take this from -70 to -65, and your radios will take a decent bump up. Or if you need it to be a little quieter, which is rarer, you could drop it to -72, or you could lower your floor. Either option will get you there. your APs will all power down. Typically, you'll use this to buoy your signal up, not reduce it as much. That's a little rarer, but there are circumstances where you may need to do it. Okay, this is where we're saying not to use defaults. If you're not really sure, we recommend just a negative, we recommend an 8 to 17 min max. That'll usually get you clear most of the time. You can do a bit more fine tuning with some practice and some trial and error. Wireless is all trial and error. There's a lot of testing. Every building is a little bit different. If you have a building made out of brick and a building made out of wood, they're going to handle Wi-Fi very differently. So it's usually a good idea to try some tinkering and see what works. Like I said, these are not impacting. You can change them pretty much at any time and it doesn't affect the clients at all. So don't be afraid to just tinker with some stuff and see what gets you better performance, especially if you're getting a lot of complaints of weak signal, no signal, or things like that. You can usually resolve that pretty easily because a lot of times the access points are just negotiating to a very low power because they can hear each other really well, but then the clients who have much weaker radios can't hear them as well. Okay, so common optimizations. So this is basically what we're going to say. If you have open power and the APs happen to negotiate into a way where they negotiate a little too loud, that AP will become a magnet for all the clients. If you have an AP that's particularly loud, clients don't put a lot of thought into what they join. They'll usually join something that meets their criteria the best, and that criteria is usually based on signal strength and then an increase in signal strength. So usually they'll look for something that has the best signal strength, and then if they're on that and they see something that has a much stronger signal, they'll usually move to that. So if you have an access point that's running at 17 dB and you have an access point that's running at 7, most clients are going to join the 17 because it's much louder. And in their mind, much louder equals much better signal, right? That's not really the case, but most clients don't think that hard, so this is something you can bump into. It's good to try and get your access points to have a fairly balanced level of power, and that would be like both of them being roughly similar in their output. This will keep you from having clients stick to one AP in particular and will let you spread them out a little more. This can also happen if you see a power imbalance. So if you have a very strong 2.4 radio and a very weak 5 gigahertz radio, you'll see a lot of clients swapping to 2.4, which isn't usually what we want. And then we'll talk a little bit about the roaming here for smartphones in particular. They, like I said, they usually pick the loudest AP they can. They have every developer for phones or any device really, they have their own proprietary requirements on what is a good signal. Apple, Android, Samsung, Google, doesn't matter, whoever makes the phone, they all dictate what the good signal is. And most of them are not the same. Most of the time, they're wildly different. They may not choose to roam at the same times. They may not choose to connect at the same times. They may choose wildly different access points to connect to based on what their settings are. This is the unfortunate aspect of wireless, is that we only control half of the equation. So we only control the access points and the controllers. We just have to try and make it work for all of the clients that are below us. So we can usually attack this by enabling features and creating our profiles based off the weakest client, as well as using any of the standard methods. So like 802.11k, VR, anything that's supported by the clients, we can usually look that up as well. Especially if you have managed clients, this gets much easier. On BYOD or guest networks, it gets much harder to manage this because we don't control the client. We don't know what they're bringing in. It gets much harder to keep track of who's doing what. So this is a slide for AIRRM that we wanted to put in here just to cover, as this question comes up quite a lot, on what are the benefits of AIRRM versus standard traditional. So AIRRM does a lot of things, but its primary purpose is that it does all of the managing of the RRM for you, and it gives you a dashboard that will tell you what it changed, why it changed, and when it changed it. So if you have a client that says they got disconnected and we look and it's like, oh, okay, the channel changed because there was high interference. It will fix that basically as soon as it sees it. And you can, with AIRRM, we have something called busy hours, where you can set a time period, say 9 to 5, and the controller will try to not make changes, or will just, depending on what you set it to, it will either try not to make changes, or it will just not make changes during that time period. So you don't have to have it run during the day. It can run after the workday and then make all the changes it saw during the day. That makes it a strong option, especially if you don't like having your APs change channel in the middle of the day and risking kicking people off. So here we can see a couple screenshots of the dashboard on the left that'll show you the overall health of the clients, if it changed channels, why it changed channels, any actions it's about to take, as well as all of the stats for the site for the customers if they're failing to authenticate, if they have weak or low signal, and co-channel interference. Sorry, I had to squint a little bit there. That image was hard to see. The downside to this method is it does require a few things to be enabled on Catalyst Center, like it requires AI analytics to be enabled, and it kicks the information up to a Sunray server in the cloud, our cloud, where it gets analyzed and then sent back. So this does require data to be exported. I believe it's supposed to be set for FedRAMP pretty soon, so we should see that go through, but it only kicks RF data up. It doesn't click client data up, so it's generally pretty safe from a data standpoint. So now we're going to talk about the policies for the WLAN and the policy profile. This is a quick recap on all the components of each individual one, but we will skip that because I've talked about it already. So looking at the WLAN profile, we have fast transition is probably one of the most common things. If you don't have fast transition on, you'll encounter something what we call slow roaming, where basically every time your client moves from one access point to another, it has to re-authenticate. This can be very slow and very poor for the client experience because they have to re-authenticate each time, which means they'll drop from their WebEx calls or Teams calls. They'll have general slowness and buffering as they move between access points. Fast transition basically allows the client or the access point to hand off the session to the next access point in line so the client doesn't have to re-authenticate. They send about 3 packets and then they're back on their way. You can usually roam without losing any pings if you have fast transition on. The most common method we have right now is what we call multi-mode. So that's what we show here, where you have fast transition set to enabled. And then under the auth key management, you'll see 802.1x, and then you'll see FT 802.1x. So what this basically says is if your client doesn't support fast transition, we'll let you on the network. If your client does support fast transition, we'll let you on the network. So this is a good mixture. Most devices made in the last 5 to 10 years support fast transition. It's a pretty widely adopted feature set now. So we early on, probably 5-6 years ago, there were a lot of issues. Fast transition, almost everybody's had to turn it off at some point from TAC cases. For the most part, it's pretty stable. You may every once in a while still bump into a client that has trouble with it, but for the most part, it's better to have it on than it is not to have it on for a majority of clients. The other option you'll see that gets commonly checked here is the over the DS. That means instead of having the access points send the packet to each other over the air, they'll send it over their Ethernet ports. If the APs are all on the same switch, this is technically faster. If there's anything that between them, like a router, a firewall, load balancer, or another switch, this slows down considerably. So we don't recommend enabling over the DS most of the time. It's better to just have the APs broadcasted over the air. Okay, so this is a fast transition for legacy clients and for Wi-Fi 6E. So adaptive cannot be used on 6E. Adaptive is basically kind of like the Illuminati of fast transition. We basically hide that fast transition is enabled by putting it in the hidden IE section in the packet header, and only clients that know it's there know where to look for it. Most clients will just see that FT is not enabled. This is really limited to particularly just Apple and Samsung, I believe, at the moment. They're the only ones that can see that header if you use adaptive. If that's fine with you, you can do adaptive. Typically, it's better for all clients if you just have FT enabled. Even adaptive has issues sometimes, and some clients have issues with adaptive. So we generally recommend just doing enabled, but if you have compatibility issues and you still want to have some clients be able to use it, adaptive is your workaround. But with WPA3, we can't use adaptive. We have to have it either enabled or off. Okay.
Sean, we are at 12:17 here, and I just want to do a time check and see if there are any questions from folks in the audience, or if Sean is okay to just continue with the rest that he has.
No questions.
No questions? Okay, go ahead, Sean.
Sure. So this last bit should be pretty quick. I do have a lot of extra slides in here,
Tom.
so I will.
Sorry, Sean, we do have a question.
Oh, sure.
Thank you. Yes, I do, but I can wait until the end for my question. So if I could ask it now, or should I wait?
Go ahead.
So I'm wondering about the transmit power control.
Mm-hmm.
What is the best tool to analyze and how to troubleshoot if we make some changes?
The best tool is usually Ekahau, but you can also just use your client. There's some
The best tool is what again?
Ekahau.
Spell that for me.
Ekahau sites. It's EKAU, or sorry, EKAHAU.
Okay.
It's a site survey tool. It's the best by far, but you can use pretty much anything that tells you the signal strength. Apple will do it natively, but with Ekahau, you can get what's called a sidekick, which is basically a radio that just listens, and you can walk around and collect data on the floor to tell you how strong the signal is and where it's weak, and that'll give you the most conclusive data. It's also not expensive holistically, but it's more expensive than a free app. So it does cost some money to make that work because you have to buy a license. But if you're going to be doing a lot of RF, or you do a lot of RF, I highly recommend having Ekahau as either a sidekick or even just the app with a dongle, or your device's native wireless will give you the ability to map out how the client sees the wireless network much better.
Great. Thank you.
Mhm. Is that the only question?
Yeah, you're good.
Cool. Okay, so I have a lot of slides. There's a lot of slides in this deck. I'm not going to cover all of them, so you guys won't have to fall asleep in the middle of lunch. But I am going to cover these next few as they are fairly important for the controller. Pre-1712, our session timeout was 1800, which is terrible. I've argued with the BU a lot for this one. 30 minutes means that the session timeout is an absolute value. So 30 minutes means every 30 minutes your client gets kicked off no matter what. There's nothing you can do to stop it. As a client, there's nothing you can do to prevent it from happening. You get kicked off every 30 minutes. So if you forget to change this, you'll get a lot of complaints about being continuously disconnected, especially, and if you get a bit more data, sometimes the clients aren't able to give you the time frame, but typically you'll see it happens about every 30 minutes. So we recommend increasing this. We usually recommend increasing it to roughly your workday, or you can just do a full 24 hours. Either option is fine. But the goal here is that we do not want to kick clients off while they're using the network. We only want to kick clients off if they leave. So the goal is if they stay connected, the session timeout will just let them stay as long as they're online. And then if they go idle for a certain amount of time, we'll kick them off the network. That's usually how we look at this. And the goal is to keep the client table as trimmed as we can, so it has the most up-to-date information. And two, to free up IP addresses and things like that from clients that are no longer using it. Okay, so cutting the chatter. This is to discuss a few things that we'll see on wireless networks that can chew up a lot of time that are not wireless. So a big one is MDNS, multicast, security scans, things like that. There's a lot of data that can come through the network that you may or may not care about. A popular example will be Windows does something when it joins called SSDP, which is a simple discovery protocol. And it's basically just trying to find printers and other things that it's connected to in the past to see if it's still available. Now, individually, this isn't a big deal, but if you have a few hundred clients connecting their laptops all at once, you get a large wave of SSDP traffic. The traffic itself is not always a big deal, but sometimes it can cause a lot of issues, especially on Fabric, or some of the newer switches have issues with this type of traffic. So we usually recommend just creating like an ACL or something to block it. We also recommend, if you're not doing MDNS or multicast, that you trim up that wherever you can, because that type of traffic can propagate much farther than you want it to, and it can consume a lot of resources. So there's a few different ways to do it. This has like a base ACL for SSDP, as most enterprise networks don't utilize SSDP. They usually have another discovery mechanism in place, but it is a good one to be aware of as it can just chew through network resources quite quickly. And then we'll come around some troubleshooting tips and tricks. So radioactive traces are probably my absolute favorite thing on the 9800 by far, and I like not a lot about the 9800. An RA trace basically allows you to add a MAC or an IP address. I highly recommend MAC address over an IP if possible. And it will basically run conditional debugging on that client for every event until you tell it to stop. Now, this uses a circular buffer. So as the buffer gets full, it will just override the oldest data. So you don't have to worry about it filling up your flash. It won't crash your controller if you leave it running. If a customer tells you they have a problem, you put them in the RA trace tool, you click start, which turns on the debugging. If you don't click start, it only gives you always on logs. And that's basically like syslog messages. They're not very useful. You have to click start. And over here at the top, you should see it will say conditional debug state started. This will just run debugs on this client, and as soon as they encounter the issue, you can generate logs for a time period that you designate. So if client calls you and says they have an issue, you have their MAC address in, and you tell them to just let you know when the issue happens again. They call you and say, oh yeah, I had the issue yesterday at noon. We can generate logs from the last 24 hours, go back and look and see, oh, okay, yeah, I see the issue you had. It was this is how we'll fix it. This is great because we no longer have to sit there with debugs enabled and just wait for the client issue to happen. We can collect it, debug it, and then shoot it off to TAC if we're not sure. There is a little checkbox here at the top that might be difficult to see in the screenshot. I apologize. That says enable internal logs. Please don't click that unless you're asked to. It basically has the controller dump every time it queries a database internally, and it makes the logs about 35 times longer than they usually are. So instead of being 4 lines, it'll be about 45 lines. So it makes it quite difficult to read. And unless they ask you specifically for that, just leave it unchecked. And then I will skip past these in the sake of time, as they're just some scenarios that we can review later. So for troubleshooting tools, we have the RA tracing tool, which will tell you basically just how to start the RA traces like I just covered. We have AP traces, and we have over-the-air packet captures, which are a little harder to set up, but they're useful when you need very specific information. We have some common issues, which I will skip past. Here are some favorite tools that we like to use. Wi-Fi Hawk is a way to analyze over-the-air captures. WCAE is a config analyzer, which is fantastic. It's upkept by one of our principal engineers, and basically you can upload a Showtech wireless to it, and it will break down best practices, SSIDs, rogues, and all kinds of other information that's very useful. And as of the latest update, it actually has a GUI interface. It used to outpoint into just a very large Excel file, which was much less user-friendly, but this is good for generating reports or just making sure that everything is good. Then we have some Intuit bits. We have, obviously Wireshark. We have our couple tools, and down here you can see the site survey tool I was referring to called Ekahau, in this case Ekahau Pro. This site does have links to all the websites if you're interested. I do not know why I just clicked that. There we go. There's also some NetOps tools, which are very useful. There's some good stuff in there, as like the WCAE tool and the WLAN Polar are both very useful for doing large-scale pushes. Some devices have some native troubleshooting, like iOS Wi-Fi diagnostics, which is actually quite useful. It'll give you a lot of things, including the signal strength, and as well as like gateway reachability, ping test, and a few other things. So if you just need to do testing with a client, some of the built-in features are good. Then we have, of course, Catalyst Center, which will show you analytics, client details, and a bunch of other things. That would honestly take well over an hour for me to go through by itself. So we'll just keep it short here so I don't shoot through everyone's whole day. And that will basically end it for me.
Thank you, Sean, very much. Any questions for Sean at all? No questions? Hold on.
We have several small offices at remote locations.
Mhm.
So let's say we'll have maybe 3 APs, but there's many other businesses in there. So
Yeah.
there's a lot of interference, co-channel interference, a lot coming from other APs that we don't control.
Okay.
What is the best way to work around that particular situation? Because it kind of messes with the RF health of the few
Absolutely.
APs that we have.
So the best method is to the best thing to do is to work with the neighbors if you can, right? If they're amenable to it, it's usually better for everybody because you just end up stepping all over each other and it makes life hard. If you can work with them, the general goal is we want to reduce the power as much as we can to only cover the building at like enough of the level, right? We don't want to be blasting too loud and we don't want them to be blasting too loud. So we want to try and keep the power levels as low as we can get away with. We also, if you can work out like a channel plan with them where you guys agree to avoid certain channels. Like, we'll take 36 through 64 or something, right? We'll take Uni 1 and then you guys can take Uni 2. And that way you're not stomping all over each other's wireless. That's a good method. It does require you to communicate. If they don't want to cooperate or you can't get a hold of them, which is usually the issue, we can have the controller try to avoid interference and we can just try and control our power levels as much as we can to not cause too much overlapping interference. Also reducing down to like a 20 megahertz width would do a lot because it'll help free up a bunch of channels.
Good. Any questions from online? Kim, if I remember correctly, you were joining virtually. Do you have any questions for Sean?
No, not at this time, but thank you.
Okay, good. Well, please join me then in thanking Sean for putting on a great presentation.
Thank you, Sean.
Thanks, everyone.
And please join me in thanking Alan and the CHP team for hosting us.
Thank you.
And quickly, so that we can do the networking, how about you tell us where you're from?
Network Tech here, CHP, Brian Guthrie.
Okay, how about you just take the mic?
Julian Carrasco, Network Tech CHP.
Vinny Camino from the WAN team, Network Tech.
Stephen Alfaro, Network Tech. CHP.
Sean Hickox, Network Architect at CalSTRS.
Network engineer at CalSTRS. My name is Ron.
Caleb, Network Security, CHP.
Eric Salinas, CHP, Network Security.
I'm Kennedy Dobria from CHP Network Security Group.
Paul Thompson, CDTFA.
Blake Barrow, Solutions Engineer at Cisco.
Linda Rich, I'm the Program Manager for the State of California at Cisco.
Ashish Naveen, I'm with Cisco, Client Executive Strategy and Execution, helping our customers.
I'm Dan McMorrow with Cisco on the networking exec team.
Hey everyone, Eric Boucher. I'm a solutions engineer with Cisco covering CHP, so I know Alan real well. Also cover Caltrans and some of our other large accounts. Really quickly, I just, number one, wanted to thank Yuli for putting this together. And again, Alan, thank you for your help. I wanted to let you guys know, if you want any kind of follow-up, please let me or Blake know. You might be one of our accounts. If you're not, we can get you in touch with your SE, which would probably be Scott Herman. So any follow-ups to this, if you liked what you saw, let us know. If you have any suggestions for future sessions, also please let us know.
Yeah, I give Yuli a whole list of stuff to set up some more of these, some other ones. So. You want to?
Hi, I'm Leroy Boren, and I'm a network engineer for Caltrans.
And Kim, do you want to introduce yourself?
Hello, I'm Kim Osaki, and I'm with JCC, and I'm a network analyst.
Perfect. Awesome, Sean. Thank you again for your time, and you're free to hang out. How much time do we have, Alan, for the?
I got the whole day, so this place is for the whole day.
Okay. Did you have anything?
I was like, making sure it was covered. I didn't know what was going to be.
I appreciate you doing that. Yeah, well, feel free to hang out and network, but that concludes the session. Thank you all.
Thank you.